Good morning students. Today we will discuss how to calculate overall heat transfer coefficient in double pipe heat exchanger. One area of heat transfer is given and the flow rates are given. Then how to calculate the overall heat transfer coefficient in case of double pipe heat exchanger. First we will read the problem clearly. Determine the overall heat transfer coefficient for a parallel flow double pipe heat exchanger to cool 55,000 kg per hour of alcohol from 65 degrees centigrade to 40 degrees centigrade using 40,000 kg per hour of water entering at 5 degrees centigrade and leaving at 35 degrees centigrade. The specific heat of alcohol is 0.9 kilojoules per kg per Kelvin. Area of heat exchanger is 130 meter square. So, before starting the problem, the very first point we should decide here is, right, which is hot fluid and which is cold fluid. Hot fluid, then cold fluid. Determine the overall heat transfer coefficient for a parallel flow double pipe heat exchanger. Given is dPHE and parallel flow. This is the information given. The heat exchange equipment is double pipe heat exchanger and the type of contact is parallel flow. In using this double pipe heat exchanger, using parallel flow contact, it is desired to cool 55,000 kg per hour of alcohol. So, alcohol is to be cooled from 65 to 40. Therefore, hot fluid is alcohol. Then, cold fluid. How this cooling is done? Using 40,000 kg per hour of water entering at 5 degrees centigrade and leaving at 35. Water is entering at 5 degrees and getting heated to 35. Means water is gaining all the heat that is lost by alcohol. Alcohol is entering at 65 and coming down to cooling, getting cooled to 40 degrees centigrade. So, which one is cold fluid? That is water. Once you write like this, then afterwards when you write notation, it will be very easy to you. Whenever you are writing m dot h, okay, h is hot fluid, like that, that is alcohol. Like that you can pick out very easily. So, first you start like this: hot fluid, alcohol; cold fluid, water. Now, what is the given information? We will write first. The given information is what? Mass flow rate of alcohol is given. Mass flow rate of alcohol. Alcohol is hot fluid. Mass flow rate is m dot. M dot is mass flow rate. Alcohol is hot fluid. So, it is denoted by m dot h. So, how much it is? M dot h. 55,000 kg per hour. Next, mass flow rate of water is also given. Mass flow rate of water is equal to, mass flow rate is m dot, water is cold fluid, so C we represent by C, that is 40,000 kg per hour. So this is the information regarding flow rates of hot and cold fluids. Now, the other information that is given is entering temperature of alcohol, that is hot fluid. Entering temperature of hot fluid. Hot fluid is alcohol is equal to TH. TH indicates hot temperature of hot fluid entering, THA, that is equal to 65 degrees centigrade. And and leaving temperature of hot fluid. Leaving temperature of hot fluid is equal to THB. B indicates leaving temperature. So that is equal to 65 to 40 degrees centigrade. So THB is 40 degrees centigrade. Next, cold fluid entering is 5, leaving is 35. Then entering temperature of cold fluid is equal to represented by TCA, that is 5 degrees centigrade. Then leaving temperature of cold fluid is equal to TCB, that is 35 degrees centigrade. Okay. Then what else other information is given? Specific heat of alcohol, that is specific heat of alcohol. Specific heat of alcohol is represented by CpH. Since H indicates hot fluid, alcohol is the hot fluid, specific heat Cp, this is 0.9 kilojoules per kg per Kelvin. Then the last piece of information is here, area of heat exchanger. Area of exchanger, that is 130 meters square. So we wrote all the information that is given. Next, what is the question? Overall heat transfer coefficient. Overall heat transfer coefficient U is equal to how much? That is the question. When the question is like this, overall heat transfer coefficient, it is not mentioned whether U is based on outside area or based on inside area is not mentioned. In the same way, area of the exchanger based on, is it based on outside surface of the inner pipe or inside surface of the inner pipe, that is not mentioned. In such case, you always assume this as based on outer surface of the inner pipe wall, and this also assume it as U naught. U naught means overall heat transfer coefficient based on A naught. A naught is what here? Outside surface of inner pipe wall. Why inner pipe wall? Why inner pipe wall? Because inner pipe wall is separating hot and cold fluids in the double pipe heat exchanger, like this now. Here this is here suppose this is hot fluid, anywhere we can say suppose this is hot fluid and this is cold fluid, then like this. Okay, this is parallel flow only, this problem anyway. So this is cold. So this is the wall which is separating hot and cold fluids. That is why this is inner pipe wall. Inner pipe wall. So this inner pipe wall only is important to us. So this is outer surface of the inner pipe wall and this is the inner surface of the inner wall pipe. So here U naught you have to assume that it is understood that it is a U naught when nothing is mentioned. So this is everything we wrote what is given in the problem. Now we will plan out how to calculate U naught. Based on the data given, we need to select the equation. Based on the data given, we need to select the equation. So Q equal to U naught, A naught, then delta T ln. This is the equation you can use. Q is equal to U naught, A naught, delta T ln. So you need U naught, isn't it? So Q by A naught delta T ln. So this is the second equation. Using this you can calculate. A naught is already given. This is A naught. And delta T ln, calculate. Calculate delta T ln for parallel flow. For parallel flow. Okay. Then Q, how to calculate? Q, based on the information, you can use the equation. What information is given? For example, in this problem, alcohol is the hot fluid. Alcohol information is completely given. That means Q equal to m dot CPH, m dot H CPH into THA minus THB. This equation you can use. Okay. Q can be calculated like this. MCPDT for hot fluid. M dot H is given in the problem. CPH is given in the problem. THA, THB all are given in the problem. So calculate Q using this. Calculate for parallel flow LMTD. A naught is given here. So then you can calculate U naught. This is how we plan the problem. So now shall we calculate first Q. Q is equal to m dot H CPH into THA minus THB. So what is m dot H value? M dot H is what? How much it is? M dot H 55,000. 55,000. And CPH is 0.9. And THA is how much? 65. And THB is 40. Okay. So like this we need to substitute all the values. Now you should be careful in writing the units, because when you are doing calculations you need to check once properly whether the units are consistent or not. In order to do the problem correctly, you better follow this method. Below this you substitute the units and check. What is 55,000 here? That is kg per hour. And 0.9 is what? Kilojoules per kg per Kelvin. And this is Kelvin. Okay. So kg, kg. Kelvin, Kelvin. This is centigrade. Already I explained you. This is centigrade, this is centigrade. But plus 273 you are adding. Here also 273. Both, because this minus plus both gets cancelled. So centigrade or Kelvin both are same value. So this you will have now so much of kilojoules per hour. Q is equal to, its value is 1237,500. Okay. This is Q value we got. We got the units, kilojoules per hour. Is it? Please check the value of Q. What is Q? Rate of heat flow. Means quantity of heat transferred in unit time. So kilojoules is quantity of unit heat transferred. So many joules in 1 hour. So this is nothing but the unit of Q. Next what? Q calculation is over. A naught is given. So next is delta TLN. So calculation of delta TLN. calculation of delta. Whenever you are calculating delta TLN for double pipe heat exchanger, first you write which contact it is. So parallel flow contact. So for that, follow this method which we have already discussed in previous classes. First write the cold fluid inlet temperature and outlet temperature. How much is cold fluid inlet temperature? This is 5 degrees centigrade, and outlet temperature is how much? 35 degrees centigrade. Okay. Now because it is parallel flow, same direction, the other fluid also flows. This also enters here. Hot fluid entering, cold fluid entering at the same end of the exchanger. So this is THB. And how much is the TH value? That is 65 to 40. So this is 65 degrees centigrade and this is 40 degrees centigrade. Okay. Like that, if you draw this just 2 lines, it's enough. You can calculate very correctly LMTD. So here, let it be delta T1. Delta T1 is the temperature difference at the entrance. Whether it is parallel or counter, the difference is delta T1 is always taken at the entrance and delta T2 is taken at the exit. So in this, delta T1 equal to THA minus TCA, that is equal to 65 minus 5, that is equal to 60 degrees centigrade, and delta T2 is equal to THB minus TCB. This is equal to 40 minus 35, this is 5 degrees centigrade. Okay. So now delta T ln LMTD, delta T ln is equal to delta T1 minus delta T2 by ln delta T1 by delta T2. When you are taking T1 first, here also it should be T1. So that is 60 minus 5 by ln 60 by 5. This value is 22.13. This value is 22.13. This is again same explanation here. Here this unit and this unit gets cancelled. So the unit of delta T is again temperature, either degree centigrade or Kelvin. Both are same because you are adding and then subtracting. Delta T equal to T2 minus T1. You are adding 273, subtracting 273. So this is delta TL. Now we are having all the required values. So calculate U naught. Q is equal to UA delta TLN. So Q by A naught delta TLN. Okay. What is Q value? 12, 37, 500. That is the Q value. And A value is what? A naught value is 130 meter square. That is 130 into delta TLN 22.13. So this again you need to write the units. What is Q? Kilojoules per hour. That is Q divided by, this is kilojoules per hour, and this is what? Meter square, and this is what? Kelvin. Okay. So what is the value is 430. It is, the unit is kilojoules per hour per meter square per Kelvin. This is the overall heat transfer coefficient. Overall heat transfer coefficient. Of course, based on A naught, that is understood. Based on A naught. Thank you.